All right, hey there, welcome to the intro video for our new unit, which is going to be Unit 12 on histograms, which means you're probably noticing that we're off to a great start with a typo. The very first thing I want to point out is that it should say Unit 12 in your packets for histograms. We just finished up Unit 11 on transformations and quadrilaterals, so make sure you're looking at this thing now that just you got that it says Unit 12 on histograms, okay? All right, so we're going now with Unit 12 on histograms, and in the last class, after you guys finished up the horizons, I had you complete a bar graph activity where you had to just tally and create a bar graph for the different types of comic books. And so I included a screenshot of that here because hopefully that looks a little bit familiar. So I can just kind of talk to you guys at the beginning about just the differences between the bar graphs and what we're going to be exploring in this upcoming unit, which are the histograms. All right. Now, the first thing I want to use are some words from science class that hopefully will sound familiar, the words qualitative versus quantitative. And generally, our bar graphs show qualitative data. For example, Superman and Spider-Man, those are qualitative data. And when we switch over to histograms, we start usually looking at numerical data. So like our months in the year, we would look at months 1 through 3. Here, 4, 5, 6 for April through June, and so on. So the big thing I want to point out from the beginning is that they generally represent different types of data. The bar graphs actually have spaces in between the bars. You'll see right here between Superman and Spider-Man, there's a space. There's a space right there. I'm kind of highlighting up here that there's some spaces. Where you'll notice on the histogram, there are no spaces in between the bars. Now, the reason that that happens is because down here, we switch to intervals, and from January to March is an interval, and then April to June is another. I'm going to talk about the intervals a little bit more on the next page, but I just wanted to point out that that's why there's no spaces here. Now, what they both have in common, y'all, is that the height of each bar shows the frequency, so that's something that they both have in common, which means that for each of them, you can find the total by simply adding up the heights of each bar. In the practice example where you had to give me the number of people who I think it was the number of sold, 2 Superman comic books were sold, and it looks like 6 Spider-Man and so on. So you can add up the heights of each of these bars to figure out the total number of comic books that were sold. Same thing over here, whatever data this is representing, if we want to see the number of books that were sold from January to March or from April to June, if we want to see the total number that gets sold, we can just add up the heights. Another thing that they both have in common, y'all, is that the x-axis is going to always represent your independent factor. So down here on the x-axis, this is independent. And what they both have in common is that here on the y-axis, this is always going to be the frequency, and it's the dependent factor. Sorry about that. It's a dependent factor. So these are just the features, and I wanted you guys to go ahead and take notes on that. And as the video unfolds, you guys will be a little bit more comfortable with what I meant by all of this information. Now, what you're looking at right here, again, is just me going from a frequency table to a histogram. It's another example down here where you can see that we have numerical data represented in intervals. And because this interval is from 71 to 75, there is no space from here to here. And so we're going to kind of formalize this a little bit more if you guys want to flip over with me now. And we can take notes here on some vocab. So the first thing that I was kind of looking at over here onto the left is something called a frequency table. And a frequency table is generally the process of you tallying the data as you collect it. So this is kind of you getting and gathering the data, and then this is how you kind of formally want to represent it. So when we formally represent it, we're going to put it into a histogram. And again, it's a lot like a bar graph, except the categories are now quantitative. Remember, the N in quantitative can help you remember that it's numerical data. So we've got numerical data down here. And the numerical data is represented in intervals, which again, you can see the intervals are right here. Now I have, once again, that the height of each bar shows the frequency. So the height of each of these bars shows the number in each category, which is what I mean by frequency, the number in each category. All right. And like I keep emphasizing, there are no spaces between those bars because, again, they're intervals. And so you either fall into this category or this category, and there is no space in between the categories. All right. Cool. Now to kind of start to get comfortable with these, we're just going to start real quick by looking at this interval right here, the 86 to 90 interval, which is this one right here on the histogram. All right. So if I wanted to just ask a basic question that's like, hey, what's the frequency of this interval? You would tell me that it's 4. And you could see it right here, here, and then also right here. And what would that indicate? What that indicates is that if this is a frequency table showing the number of students who scored within a certain range on a test, it means that 4 students scored between an 86 and a 90. Now, we do not know what scores they actually got. For example, it could be an 88, an 88, an 88, and an 88. All 4 of those scores could have been 88s. Or one of them could have been an 86, an 89, another 89, and then a 90. We don't know what those scores are, but we can at least say that there's 4 scores in that range, okay? So that's what that means when I say like the height shows here the frequency. It means that right here there were 4 in this interval. There were here, if you look carefully, it's between 4 and 6, so there must be 5 in this interval. There would be 4 in this one. It looks like this one would have a height of 8, so there's 8 who scored in that range. There are 7 who scored in this range, and there are 9 who scored in this range. And you can see that the heights of those line up here with the frequency, which is the number in each category. Okay? All right. Now, can we determine the highest and the lowest scores using the histogram? No, we cannot. Because even though there are 9 students who scored between a 96 and 100, we have no way of knowing what the highest score actually was. These intervals are meant to be consistent intervals. So like if the first one goes from 71 to 72, 73, 74, 75, the next one is supposed to have the same range and then same here and here and here. So the range going from 96 to 100 doesn't necessarily mean that somebody got 100. It just means that there's 9 students who scored within this range. Similarly, we could not tell the lowest score, even though that I see 5 students got between a 71 and a 75. I have no way of knowing if those students got 71s or 72s or so on. So they could have all gotten 75s, or one of them could have gotten a 71. So therefore, again, I cannot tell what the highest and the actual lowest scores actually are. What I can do is see how many students scored less than an 86. So for example, if I find the 86 here, 86 is right here. So less than an 86, if I draw a line, it's all of these folks right here. So less than the 86 would be these 5 plus these 4 plus these 8. So 5 plus 4 is 9, plus 8 is going to be 17 for this one. So I can see that 17 students scored less than an 86. Now, if I want to see how many students scored more than a 90, I can again look and say, okay, so here's the 90. So more than a 90 would be these students. Or I could say the 90 is right here. So more than 90 would be these students right here. So you've got 7 plus 9 or 7 plus 9. Either way you look, we get 16. All right. For the next question, how many more students scored between a 71 and an 80 than the 81 to 85 range? Okay, so let me just kind of erase this stuff here. First, I'm going to look at 71 to 80. So 71 to 80 is from here to here. And then we're going to look at 81 to 85. So 81 to 85, we're going to compare it to this green box. So again, 71 to 80 is everything here. It's these 5 and these 4. So we've got 9 versus the 81 to 85, which is right here, which was the 8. So how many more in this blue category versus this green category? It looks like there's just one more. One more. So sometimes the questions might be worded in a way that prompts you to look in more than one category when you're grouping it together. Kind of like here when it said 71 to 80, it's asking you to pull all of these students together and say there's 9 in that category compared to this 8, which is one more. All right, another question I could ask is which interval contains 5 more scores than the 86 to 90 interval? So let's find the 86 to 90 interval. and we can find it in both places. 86 to 90 is right here, and 86 to 90 is right here. So which interval has 5 more scores in it than this category? Now this category has 4 students. So we want to find a category that has 5 more in there. So 5 plus 4 is 9. So we want the category that has 9, which is right here. This category has 9 students in it, which is 5 more than this. So it's the 96 to 100 interval. That interval contains 5 more scores. There's 5 more students who scored in that range than who scored in this range. All right, for the next question, if it asks how many students scored between an 81 and a 90, so between 81 and 90, it does want you to group these two together. So it wants these 4, 81 to 90, plus these 8. 81 to 90 is also here in the chart. So 81 to 90 would be these 8 plus these 4. So we get 12 students in that chunk. All right, and for number 9, how many fewer students scored from 71 to 80 than 91 to 100? So let's come up here. I'm just going to erase real quick. We're looking for how many fewer in one category compared to another. So 71 to 80, 71 to 80 had 9. 71 to 80 right here is these 5 plus these 4, so 9. Now the other one that we're comparing to is 91 to 100. 91 to 100 is going to be these 16. 91 to 100 is going to be these 7 plus these 9. So we get 16 here compared to 9 here. And it wants to know how many fewer are in this category than this category. So if you subtract 16 minus 9, we get 7. There's 7 fewer in this category. All right, now a couple words from elementary school that might ring a bell would be mean, median, mode, and range. Now when I say those 4 words, I'm going to discuss 2 of them right here in the video. So mean and range, okay, let's just review what those are by definition. So the mean is when you find the average of a data set. And when you find the average of a data set, you basically have to add everything up and divide by how many there are. Now, we can't find the average because we actually don't have the data to add up and divide. When I look back up here at Ms. McGrath's class, I can see that, yes, I can add this up and see that there are 37. If we took the time to add all these up, there would be 37 students total in this class. So there are 37 test scores, but I don't know what the actual grades are to add them all up and divide by 37 to get a class average. Once again, I know that 8 people scored somewhere in here, but I don't know what their actual grades were to actually add them up and divide. So I cannot find the average or the mean looking at a frequency table or a histogram. We cannot find the mean. Another thing we cannot find, y'all, is the range, because the definition of range is when you take the highest number and subtract the lowest to kind of see how spread out the data is. Now, if we don't know, we already answered it, we can't determine the highest and the lowest scores here because we just see what category certain things fall into. So since I don't actually have the highest test score and I don't have the lowest test score, I can't subtract them to see how far spread out they are to find the range. So no, we can't find mean, and no, we can't find range, okay? Now, when we flip over, we're actually going to start to learn here how to represent the data in the histogram. So all I've done so far on the first couple of pages is kind of just given you the ins and outs of what we can look at and what kind of information we can get from the histograms. And now we're going to actually learn together how to build the histograms. We're going to take this data set right here and we're going to organize it together into this frequency table. Then we're going to put the data into this stem and leaf plot, and then we'll be able to make a histogram together, okay? So at this point, what we're going to do is we're just going to practice taking data, and we're going to first collect it and put it into this frequency table. Now, what we're looking at here, y'all, we've got the ages of people who attended the last town council meeting are shown below. So there's a town council meeting. We don't know how often they have them, but we're going to look and see here the average, or not the average, just the ages of the people who are attending this town council meeting. And then we'll look below at some questions to kind of analyze a little bit the graph that we get, okay? Now, town council meetings are usually going to be people who really care a lot about what's going on in the town that they live in, really motivated to go and make change. So let's kind of see what age group we have. We have some intervals here where we're saying 31 to 40-year-olds. And notice that we don't even bother looking at teenagers or people in their 20s, because people who are teenagers, obviously, I mean, up until you're 18, you can't even vote, so you don't really have a say in much. And then usually when you're in your 20s, you're kind of learning the lay of the land and you're just kind of figuring out life, and you're not really going to town council meetings trying to really make change happen. But once you kind of get a little bit older and you're in your 30s, then you might actually find the time to go to the town council meetings. So that might be why the ages here start in the 30s. And so if the first age is 57, 57 falls in this range. 36 falls in this range. 48 would fall in here. 52 goes here. See how I'm crossing them out as I go? That just means I'm not missing anything. I can also kind of count and say, okay, so far I have 4 things crossed out. I have 4 things down here. A 71 would be in this category. A 38 would be in this category. A 53 is right here. 62 would go here. A 70 would go here. A 54 would go here. Now we're at 31. Now we got a 44 in here. And if you want to pause the video and tally yourself, you can, or just honestly, you can wait for me. I might have missed that with the 58. 1, 2, 3, 4. See, as soon as I started talking, I'm going to come back to see if I got that one in there. But you could wait for me to finish, and you can just count them up and put them in the, once I'm done talking in the video. I got a 75. I got my 67. 72 goes in here. 61 is going to go here. A 44 I got here. Let's see, a 32 is going to go here. And then a 55 is going to go 51 right here. And it looks like with this one, the one that I wanted to check on, the 58, I didn't include it. I'm going to put it there. All right, so we've got all of the numbers accounted for. And to verify, I can count up the frequency in here. I've got 4 numbers. I got 3 that I tallied here. I got 6 that I tallied in here. We have 4 that I tallied in here. And we have 3 that I tallied in here. Now the cumulative frequency, all it does is check to see when you get to this last box, as the things accumulate as we go up, did you get the same number that you were supposed to? So for the first number right here, like as of right now, when I add them up, I only have 4. But when I do the 4 plus this 3, I now have 7 pieces of data. When I do 7 plus these 6, I now have 13 pieces of data. When I do 13 plus 4, I got 17 pieces of data. And now the 17 plus these last 3 gives me 20 pieces of data total. So let's just come up here real quick and recount and make sure we had 20 things so we know we didn't miss anything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the first step was to take all of the numbers and organize it here into the intervals. All right. Now, another way to look at this when we think about people who attend these meetings is, like, obviously if you're in your 30s, 40s, 50s, 60s, 70s. So here, looking at the stem and leaf plot, if you're in your 30s, like what that's saying is anybody here, this is a 36. Let's find, we've got a 38. So somebody who is 36 is in this category. Somebody who is 38 is in that category. And somebody who is 32 is in that category. Think, was there another one? Yep, there's a 31. Cool. All right. So one way to organize data is here into a frequency table. Another way is to organize it into a stem and leaf plot. And both of these can provide information when building a histogram. All right, so if I look for anything that was in the 40s, again, looking back up here, I got a 48, I got a 44, and another 44. So 48, 44, and another 44. All right, now if I'm looking for some stuff in the 50s, we got a 57 and a 52 and a 53. So a set of 57, a 52, and a 53. We got a 54, and a 58, and then a 55. All right, when looking for stuff in the 60s, we got a 62, a 67, and a 61. A 2, a 7, and a 1. And last but not least here, looks for the 70s, we got a 71 and a 70. So a 71 and a 70. And then a 75 and a 72. 75 and a 70, whoop, and a 72. All right. Now, when looking at the stem and leaf plot like this, we just want to take it one step further and organize it from least to greatest, which we could have organized these numbers from least to greatest in the beginning and then had a stem and leaf plot. I think organizing all of these from least to greatest takes longer. I think it's easier to just go through and to get all the stuff in your 30s, then 40s, 50s, and so on, and then come through and say, okay, so this was a 1, 2, 6, 8, done. This was a 4, 4, 8. We had a 44, a 44, and a 48. Done. We had a 72, a 73, or sorry, 50. What am I saying? 70, sorry. 52 and 53. I think I saw the 7 there when I said that. But a 52, 53, and then a 54. We had a 55, a 57, and a 58. Now, I'm sure as you're taking the notes right now, you're just like, this is kind of stupid. Like, why do we have to do all this? I'm just showing you all the different ways you can be collecting data. I've seen on an SOL them give a data set like this and say, hey, take this data and put it in a frequency table. I've also seen them say, hey, take this data and put it in a stem and leaf plot. So that's why I'm kind of just showing you guys both, even though it feels a little bit long watching me do it. The 60s here, we had a 61, a 2, and a 7. So 61, 2, and 7. And then for in the 70s, there was a 70, a 71, a 72, and a 75. Okay. All right, so what we want to do now is we want to take the data that we've organized into the frequency table and the stem and leaf plot, and we want to build a histogram. Now, when we build a histogram, the first thing that I want to point out that we need to have is a title. So the title of this we can put, I'll type it in here. I'm going to put the ages of people who attended a town council meeting. All right. Give me a second to kind of show you how much space you might need for that. I could probably make the font a little bit smaller. All right, cool. So ages of people who attended a town council meeting. That's the title of our histogram. Now for our intervals, we have 1, 2, 3, 4, 5 intervals. And when I look across here, I see that we have 15 spaces. So I'm going to devote 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And now I'm ready for my intervals. We've got 31 to 40. Let me just get a little bit of a thinner pen here. So our first interval is going to be 31 to 40. There we go. Then it's going to be 41 to 50. Then 51 to 60. Then 61 to 70. And then 71 to 80. So those are the intervals. And what that axis, or the axis, I was going to say axes is plural, that axis represents is the ages in years. So ages in years. So we've now labeled this axis. All right. Now the height is frequency always, and it looks like the most in any category up here is 6. So it's okay if we just go by ones, 1, 2, 3, 4, 5, 6, and then it of course would be 7, 8, 9, 10. So we can see that this just goes by ones, and here we'll put the frequency. And like I said, if you want to just watch me and then you can build it, cool. There we go. And so in the first interval, we had 31 to 40, we had 4. So 1, 2, 3, 4. So if you want to draw a line here and then bring a line down, cool, that's the first bar. Then the next one had 3 in it. So see how I draw my line here and here. Then we had 6. So 3, 4, 5, 6 would be here. All right, then the next one was 4 again. And then the last one was 3. Now you can color these in if you want. You can kind of outline them if you want. But what I like to do to just verify is to come back through and say I've got 1, 2, 3, 4. I've got 1, 2, 3. This was my 6. Here this was a 4. And here this was a 3. And it lines up. So I'm good to go. And again, the cumulative frequency, adding them up, it's just saying so far I only have 4. But when I do these 4 plus these 3, now I have 7. If I do these 4 plus 3 plus 6, I have 13. If I do these 4 plus 3 plus 6 plus 4, now I'm at 17. And if I add up the heights of all these bars, I'd be at 20. That's what that cumulative frequency was showing. All right. So what's the youngest age here? Now, because we have data, because we actually can see the raw data up here, we can see that the youngest age of a person who actually attended was a 31. Now, I wanted to point out that the only reason we can actually tell that is because we can see the data. If we were only looking at this histogram, we would not be able to answer that question. Same thing with the oldest age. Because I can see the data, I can see that the oldest person here was 75. I wouldn't be able to tell based on just this, but yes, I can look because we have the data. So what's the range? Well, because we have the data listed on this page, we have the 75 minus the 31. So to find the range, we just do the highest minus the lowest. So the range here is 44. The range of the data is 44. There's a spread of 44 ages. And that's kind of the range of the age group that we see, okay? 31 all the way up to 75. But if we just had the histogram, we wouldn't be able to do this. I kind of want to point that out, okay? If we were only looking at the histogram, we would not have been able to do what we just did with range. All right, now this is a big thing right here, and I know it's been 27 minutes into the video, but this question right here is kind of a big deal. If I ask what percent of adults are less than 51 years old, okay? So I'm going to highlight it in my histogram. Less than 51 means you're either in this category or you're in this category. So less than 51 means you fall into one of those two categories. Now we can see that there's 7 people who fall in these two categories. We also can see that there's 20 people who attended total by adding up all the bars. So if I want to know what percent are less than 51, it's these 7 out of the 20 total. So we can just do 7 divided by 20 to see the percent, and that's going to be 35%. 35% are less than 51. All right. So then for the next one, if I wanted to know what percent of the adults are 31 to 50, that's another way of asking the same thing I just did. Okay. If I say what percent are 31 to 50, well, 31 to 50 are those same 7. So this is just another way of asking the same question, and it would still be 7 out of 20. So the answer here is still 35% for this one. All right, for number 6, how many more adults are in the 51 to 60 category than 71 to 80? So 51 to 60 had 6 in it versus 71 to 80 has 3 in it. So how many more? If you have 6 versus 3, it's going to be 3 more. How many fewer adults are there in the 71 to 80 category? So 71 to 80 is 3, then 31 to 40, which is right here. So how many fewer in this category than this category? 1 fewer. 3 is 1 less than 4. All right, which interval has the same number of adults as 41 to 50? Well, 41 to 50 is right here, and that has 3. So which interval has the same number as this one? This one right here, 71 to 80, also has 3. So 71 to 80 is our answer for this one. All right, and for the last question on this page for number 9, we've got The 61 to 70-year-old interval, so 61 to 70, let me highlight it here in yellow. Boop. This interval has 2 fewer adults than which interval? Well, this one has 4. 4 is 2 fewer than what number? 6. So it has 2 fewer than this interval right here, 51 to 60. 51 to 60. Okay? So that takes care of our first 3 pages of the video, and I know this was our first 3 pages of the packet. I know it was a long video. On the next page here, there's going to be another example that has another video to go along with it, and hopefully you'll have time today to watch this video so that you can do the practice in the packet as well, okay? But that concludes the video for pages 1, 2, and 3. Stay tuned for the next video on page 4. Thank you for watching.